Computers undoubtedly outperform us at math, but why do they suck at English? The answer is sequence data. Sequence data, as the name suggests, is data in sequences or lists. For example, a sentence is a sequence of words, an audio file is a sequence of sound, and a video is a sequence of frames. In real applications, sequence data can appear in different and arbitrary lengths. Sequences can appear in the output, the input, or sometimes even both. Sequence data also has the idea of time, or an order, where certain elements will just come before or after other elements. When working with sequence data, the problem with normal artificial neural networks is they only have a certain number of input units and a certain number of output units, and that number is fixed. However, for both the input and the outputs, sequence length may vary. Therefore, typical artificial neural networks are not flexible enough to work with sequence data. Additionally, artificial neural networks are not able to understand the idea of order, that certain indices just come before or after others. Recurrent neural networks, or RNNs, are special types of neural networks that can process sequence data efficiently. What distinguishes an RNN from a normal artificial neural network is the fact that it receives information from different parts of the sequence. More specifically, the same RNN layer is used recurrently on every input subsequence. The current layer receives as input the corresponding subsequence as well as the state of the hidden layers from the previous and next layers. Therefore, the RNN is aware of its surrounding context and makes decisions based off of that. Another special aspect of RNNs is that their outputs can vary in length, from a single vector to a whole sequence of vectors, if we pass each layer's output through another layer. Their inputs can also vary in length, from a sequence of vectors to a single vector. The problems with RNNs, though, is that they can't remember information for a long period of time. The amount of information remembered gets exponentially smaller as it gets further away from the current layer. Refer to this animation by Michael Fly to explain this concept. LSTMs and GRUs, or long short-term memories and gated recurrent units, are special models that can choose what information to keep and what information to forget, and therefore they are a lot better at remembering information in the long term. Often, RNNs, LSTMs, and GRUs can be stacked on top of each other to create more depth, similar to how more layers in an artificial neural network give that network more depth. Also, the encoder and decoder architecture is often used for sequence-to-sequence problems, in which both the input and the output is a sequence, but they could be different lengths. The first RNN, LSTM, or GRU vectorizes the whole input sequence, and the second one decodes it and transforms it into a different output sequence. When I built a text summarizer, I used both of these ideas. In conclusion, RNNs, LSTMs, and GRUs can be applied to almost any situation where sequences are present. These networks are extremely powerful and capable of dealing with all kinds of problems in natural language processing. To build powerful artificial intelligences, they must be able to understand the same language as we do, and be able to think in terms of sequences and orders. And this is possible through RNNs.